that. Looking good. Let's get the mass of the empty watch glass. 25.9368. Okay, so I'll carefully grab the filter paper, bring it over, let those crystals slide right off. I can gently encourage them to come off. I don't want to really scrape too hard at the filter paper. I don't want to accidentally get any filter paper off. Whoops. But I think this is pretty good. There's still a few crystals on there, but you know, crystallizations, they always have a little loss. These are nice, pretty crystals, huh? Aren't they nice? I think we should look at them under the microscope after we weigh them. Let's put it in here, see what we get. $26.2254 grams. Yeah. I said I would look at it under the microscope. Let's do it. Well, and then we'll also take IR and NMRs. So we got our microscope over here. Cell phone microscope. Put a few crystals on the bring this over to the cell phone microscope. Slide that under there, so it's under the laser pointer magnifying glass. Try to put my phone right down on there. See how it looks without the backlighting first. That's really nice, isn't it? Is it looking a little dirty? Looks like I got impurities or something in it, huh? Oop, I moved it out of the way. Interesting. Wonder if that was something already on the cover slip, or is that maybe my crystals have got some impurities, huh? Interesting. Okay, and then let me turn the backlighting on and see if it gets better. Interesting, huh? That looks pretty awesome. I like that one there. I like the look at that. That looks cool. I think I do like it better with the paper towel kind of dulling the light a bit. And then I might even like it more with no light. I'll put my hand over the light. Yeah, that's cool. Alright. I could rerun my background. I'll delete this text box too. But instead, I'll just keep the old one. It's the same day. I'm in lab, so I can run it as is. And my zinc selenide crystal is very clean. I cleaned it. You saw me clean it before, or maybe you didn't. I don't know if I recorded that. So I'll take some of these crystallized neutral compound crystals and place them on the zinc selenide crystal. There we go. If I just take the IR again like this, it won't work well because those crystals are not touching the zinc selenide crystal enough. So what do I have to do? I have to crush it down with the anvil. So I have to twist the anvil so it comes all the way down onto those crystals and crushes them. Those pretty crystals are now just being crushed into the zinc selenide crystal, and I gotta put a little torque on that so I just see the silver lining of that stainless steel. And I come over and scan my sample. There we are. Instrument. sample. Say OK to the default values and just wait. It's going to do 4 scans. And while we're waiting, I'll show you before I had the software for this instrument. It used to be all done on this screen on the instrument, and we'd have to use these commands here. We got a lot of nice buttons on here. I don't see like an Elagosa button. I don't see a Stephanie button. There's no John button, no Jesse button, but look at this. There is a Mark button. That's right. I'm on the IR Mark button. Okay, the scans are done. It says overwrite the last one, and that's what I'll do. Save the computer hard drive space. And here it is. I know what it is. This looks good. Okay, so got a lot going on. Let's bring up the vertical cursor. I can click it on. I can click it on. Is it on? No, I didn't. I can click it on. Yeah, here it is, way over here. I can click it on, or I can click it off. On again. Off again. On again. Why would I turn it on? I'm going to label stuff. Come over here. This is characteristic of one of these, the molecules we're looking for. Yes, 3,405. That's interesting. It's in the region of an alcohol, but it doesn't look like your normal parabolic alcohol, huh? And then I come up in here. I've got a signal. Oh, a little over 3,000. That's good. And here. Still over 3,000. That looks like sp3 carbon hydrogens. Oh, this one. Ooh, a little under 3,000. That looks like sp. I'm sorry, did I say these are sp3? These first over 3,000s are sp2 carbon hydrogens. This looks like an sp3 carbon hydrogen. Over here, ooh, this looks like about 1,700. So that looks like carbonyl. Okay. So I can eliminate one of my 3 possible neutral compounds right off the bat, because one of them doesn't have a carbonyl. Let me draw those out again. I think it's been a little while since you've seen those. I'm running the cozy over here. So one possible molecule you could have right now is the fluorine. Could this be the molecule that we just took an IR of? It has sp3 carbon hydrogen, sp2 carbon hydrogens. They're about 3,030. It has sp3 carbon hydrogens. They are at about 2,980 or so, less than 3,000. But that's all that she wrote. There's nothing on this molecule that would make a signal at about 1,700. So this doesn't look like the right one. You see, we have. Looks like a carbonyl there, huh? 1675. Doesn't look like that. What about benzyl? Could it be benzyl? Benzyl has a carbonyl, about 1,700, so that's good. It has sp2 carbon hydrogens, at about 3,030. But wait, that's about it. Would benzyl also have this 2,930, the sp3 carbon hydrogen, and this weird guy? No. Well, I don't think it's benzyl either. Last choice is benzoin. I'm going to draw the benzoin up different this time. I'm rotating it around a bond. Remember, it has this alcohol. So the benzoin has a carbonyl around 1,700, which we do see on our IR right there. And it has sp3 carbon dihydrogens that are around a little over 3,000, which we have on our IR as well. Does it have sp3 carbon hydrogens? It has one. There's a hydrogen right there, huh? That one would be at about 2,980, a little less than 3,000. In this case, it's even less than 2,980. It's like 2,931, but it's still in the range. And it has an alcohol signal. Normally our alcohols will show up like 3,300-ish and look like a really nice parabola. We do have something sort of in that range, but it's not a parabola. And actually, that's appropriate. The reason why it's like that is because this molecule has what we call intramolecular hydrogen bonding. See that right there? This hydrogen of the alcohol can hydrogen bond to the ketone carbonyl, make a nice 5-membered ring, and that causes your OH signal to be sharper. Like that, pretty cool, huh? So it looks like we have benzoin of the 3 unknowns. I'll label this and print it and cam scan it to save for you. I would just snap it and email it, but this computer is not online because it's running such an old operating system. It might get attacked by viruses. Microsoft no longer supports Windows, whatever this is, Windows 1920 or whatever this is. I think it's like XP or something.